Yes, hi, I'm Nikolay. How many of you use sqlc or heard of sqlc? Okay, there are some people, like 5, 10. Yes, so the title of today's talk from my side is Type-Safe Postgres Access and Cloud-Native Applications with sqlc. And I'm Nikolay, I work for Zalanda here in Helsinki office. I contributed to sqlc project, also Docker Captain, and I maintain a couple of libraries on the GitHub. Yeah, and this is me at Tuso on the lake doing this red kill with stealth. All right, so why we're talking about Postgres at KCD? So Postgres is open source and it has very permissive license. It's very popular these days, and for Kubernetes, there are multiple Postgres operators which already exist. One of them is Zalanda and powered by Patroni to manage the cluster. And Zalanda is running hundreds of databases using that Postgres operator. And then there is another operator now part of CNCF, which is called Cloud Native PG. It's Kubernetes-native. It doesn't use Patroni under the hood. And then there are like even more options how to use Postgres from Kubernetes. One of the previous talk was about crossplane, and if you use crossplane, you can manage Postgres in external clouds, but they would be shown as Kubernetes custom resources in your cloud. So yeah, so Postgres makes sense at KCD. And so sqlc is a tool written in Go, and why we are talking about Go at KCD, because Kubernetes itself is written in Go, and then Go is very cloud friendly. It has low memory footprint, fast startup. It produces static binaries also for developers. It's fast compilation time, which makes sense. Then you use agentic coding. And like you are always in the loop, like change the code, recompile, run the test. So in that sense, Go is a great language, and it's getting more popular. Maybe not that popular in Helsinki, but worldwide it is. All right. So, and this talk is about how to use to talk to Postgres from the Go. And there are multiple options. One of them is ORM, which stands for Object Relational Mapping, and there are multiple tools available in Go, which I don't recommend using myself, because like there are better tools, at least in Go landscape. So for the driver, now, like at some point of time, there were competitive drivers for Postgres, but now like there is a clear winner, and it's a PGX driver. And then, so under the hood, you need to use a PGX driver, but there are options like which API you use, because PGX provides their own API. Like you can have PGX pool for connection pool, or you can use like more like a legacy approach to use like the standard library API to talk to SQL. And then there are like options how to build the queries. Like, okay, maybe you start with just like a static, like as a string in the Go code, but if you want more dynamic, then you might want to adopt the Squirrel library, which allows you to build SQL queries dynamically in the code. And the tool in the title of this talk is sqlc, which stands for SQL compiler. So yes, and this is the logo of sqlc. So what's sqlc? It's a static code generator. So it's not AI code generator. It's a static code generator. So it should produce some deterministic output. It's SQL first approach, which is opposite of ORM. So like first you need to come up with queries you want, SQL queries you would like to use, and then after that you use sqlc to generate the code from that SQL queries. It is schema aware, and it tries to be compile type safe, so it's not always the case. But yeah, it tries to actually validate your queries at the compilation time or at the generation time, not in the production. So it tries to avoid the case that you have the application compiles, you run that in production, and the query fails in Postgres. So in the nutshell, in the middle, it's in the center, it's sqlc. So as the input, it takes SQL schema migrations. It takes SQL queries, which you want to run in your application. And then it takes SQL configuration file. And as the output, it produces the queries. So it produces the Go code, which helps you to execute the queries. It also produces specific structs, which corresponds to the output of the queries. And they're kind of type safe. And it also produces one-to-one table mapping to the structs, which I don't really use in my application. So, but it's a side product of the generator anyway. So let's consider some simple example of the schema migration. We create like a cart, items, because Zalando is about shopping online, and everyone is happy, like people who buy online and people who sell online. So like if you want to add some items to the cart, then like there is a clear owner of each item in the cart, and then it corresponds to some product ID. It has a price, which is split into price amount and price currency, and there is a private key. Primary key. Yeah. So how we start with sqlc? So I imagine we want to select like all the card items which correspond to owner, like a specific person. So this is how we would start with sqlc generator. So it's almost the plain SQL query, but then on top we have one line annotation which helps generator. So we have to tell what should be the name of the Go method, and in our case it's getCard, and we help generator by telling like how many items the query is going to produce, and the options are like it produce 0, exec, 1, many, and then there are some keywords for batch also. So batch can also be batch exec, batch 1, batch many, and there are a couple of more which can be looked up in the documentation. So let's now see. So if we generate this query using sqlc compiler, so this is what we get. So the first thing, it would generate the struct, and the struct which corresponds to the output of the query, and in our case it's select. So, and the very cool thing that it's able to resolve the types. So in the classical approach, it's more like you submit the query and then you need to know by yourself like what types it corresponds in the database, what are the types on the database, and then you're doing mapping that back to Go or like any other language. But in this case, it's actually in case of sqlc, it generates the struct as an output of the query, and it's able to resolve the proper types. In our case, it's string and time. And this is the method getCard. So it uses that struct as the output, and then overall it's quite simple logic. It executes the query. It does some housekeeping. Like it needs to close some resource, and then it's do the scanning into that card, and then it returns. So that generated code getCard, it can be used as a building block in our Go application to talk to Postgres. And this is a sqlc minimum configuration file. We need to specify what engine we use. In our case, it's Postgres, but also it supports MySQL, MariaDB. So, and also right now they're adding support for ClickHouse. So in that sense, it's not limited to Postgres. And then we need to specify where our schema migrations. So it's able to read multiple schema migrations, not just one. and like aggregate them. And then we need to tell like where are the query files. Like in our case, in the example, it was select query. And then we specify like we want to generate Go code, but in theory it supports like more languages like Python, TypeScript, but I didn't use it, and I think they're not very actively maintained. So if you would like to to contribute, you're welcome. But yeah, I use that mostly from Go, and for Go we need to specify like where we like output the generated code and like what driver we use. And as I said previously, PGX is the best option as of now, as the state of art. So yeah, so what are the pros of SQL to use in SQL? So it's definitely much less Go code, which you need to write yourself, and you can use and you can generate that, and it's not AI generated, it's a static generation code, so it's reliable, and you don't waste tokens on that. So yeah, you save on those like actions which otherwise you need to do, like yourself, query, building the query, execution the query, and doing like the row scanning and so on. So it's compile time safe, and it's aware of schema, and it tries to resolve the types of the output structs of the queries. How it's doing that? Because under the hood it uses like the real parser library of Postgres. But because the library is written in C, it needs to wrap that into WebAssembly. So it uses that library to build an abstract syntax tree. I explain more in the next slide. And yeah, so if you use in memory mode of sqlc, so it builds in memory catalog, and catalog is like what tables we have in the database, what columns we have, what are types of the columns, and so on. And another great aspect of sqlc is separation of SQL and the Go code. So you can check yourself all your SQL queries which are being executed in the application, and you can show that to some expert in SQL DBA. Like if you need to optimize a query, it's much easier if they're written in a separate file and not built dynamically in Go code. So about AST or simplify. So in this case, this is simplified abstract syntax tree. So the query, like the first query itself, is just a string. So we don't know like what exactly the structure of that. And below it's more like a structured output, like what's really the query is about, and is it a valid query? And if it's a valid query, then we should be able to build an abstract syntax tree. So it's a more structured way of representing the query. So this is what sqlc uses under the hood. sqlc works in two modes. There is in-memory mode and there is DBA mode. So in case of in-memory mode, which is more simpler to set up, but in a way it's like less reliable. It can miss some potential issues, but it's much easier to use. In this case, we provide our schema migrations, and it would parse each schema migrations into abstract syntax tree. Then it would merge them into internal catalog, which is like in-memory catalog of sqlc. And then it would go and parse each SQL query which we want to execute an application, also transform that to abstract syntax tree, and then it would go and look up the catalog to verify the query, if the table exists, the columns exist, what are the types, and then it would use those types to generate the code and do the mapping back to the Go code. So, and there is another option to use database mode. So we would run the database somewhere, maybe in Docker or in test container. We would deploy our migrations there, and then we would point sqlc to that database. it's gonna be more reliable into verification, like all the corner cases. So this is how DB mode looks under the hood. So we just apply all migrations to Postgres running into Docker container or test container, and then for the SQL queries, we also have to parse that to construct abstract syntax tree. But then for the result and the type, it would construct the real database using extended query protocol. And then it would use that to generate the code. So it's in a way similar, but then this second approach with DB mode is more reliable. It can catch more corner cases. So sqlc sounds like a great tool, but of course there are some challenges if you try to use that in production. So in here I try to summarize what are the challenges. So I think the most first thing people would mention, like about the dynamic conditional queries, if you need to search specific items and user can control like what parameters it would include in the filter and what exclude, then sqlc might sound like not the best tool because all the queries has to be static and created beforehand. And then there are more potential challenges, not saying like all of them are challenges, because I'm going to explain how to address them. So like there is an option, there are different variety of types you can create in the Go, generate in the Go structs. So sqlc allows you to choose like if there is ambiguity. And then another challenge is people might use sqlc, but then create a business logic which is going to be tightly coupled to generated structs, and it should be avoided. And also the batch operations, like insert of a date, if you want to inject like a lot of data, it's actually supported by sqlc, and I'm going to show, and transaction support. So the first challenge is about dynamic queries. So I have like a simple example here and simple use case. Like we want to find all cart items which satisfy the filter, and in our case, we want. So I want to have it a bit different. Like the owner ID, we can either provide one owner or like not provide it at all. But for the product ID, so we want to provide like a list. And then within the list, they have like or dynamics. So if we try to do that, what are the options? So we can like first, the most flexible option is fall back to Go and use Squirrel library to, but do that like only for specific dynamic query. And then we can implement that in repository layer. So yeah, but another option, we can keep SQL, static SQL code query and keep using sqlc, but leverage a short circuiting technique. So first, let's see how the Squirrel code would look like. So the Squirrel code allows us to build dynamic queries inside the Go code. So this is how the library can be used. So we can do the things dynamically. Like if you want to include the owner ID filter, we include that, but if you don't want, we don't include that. So in that case, we are building the query dynamically, and then we execute the query. But what we lose here is we lose like all the benefits which sqlc as the tool provides us. So there is still an option to keep sqlc, but then our query becomes a little bit ugly, I would say. So this is the example how this can be achieved. So now products ID, so we need to make the where clause in that way that the first part, if it's not included in the filter, then it would kind of terminate, like that's why it's called short circuit. It would terminate the whole clause, and the whole clause would have no effect. So if products IDs are not provided at all, then the first clause will be excluded from the, efficiently would be excluded from the query. It will be part of the query, but it will not have no effect. And the same goes for the owner ID, but here I show that there is a special marker in sqlc, which helps generator to use to generate the pointer for the owner ID in the struct, which is way of having an optional field. All right, so the first challenge is addressed. So we have several options, and we still can use sqlc for that. So the second challenge is about generated field types choice. So here at the bottom, I show you two options. So if you don't use any types overrides, then by default sqlc tries to use the most accurate database representation of the type, and that corresponds to the driver pgx driver pg types like UID and numeric and so on, timestamps. But this behavior can be can be overwritten in the YAML file, in the configuration YAML file. And my rationale here is to pick the types which are similar to those used in the domain models, because if we use the driver types, we have to do more mapping, more manual mapping eventually. So yeah, this is how one can override the types. So you just need to specify what is database types and what Go types you want to use, and then to have that on that structs on the right. This is the configuration which I was using. And the tricky part was that sometimes you need to add this PG catalog prefix, and sometimes it works without the prefix. But it's configurable, and PG catalog just need to be aware about that. Okay, so the second challenge is addressed. Third challenge, that business logic might get too tightly coupled to sqlc structs. So that for more advanced application, maybe it's fine for very simple application. It's one table, couple of tables, that's fine. But if the application grows, if the service grows, then it has to be avoided. And sqlc struct shouldn't leak to the service layer. The service layer should depend on the main objects. For that, we can leverage a repository pattern. And what is repository? Repository, it accepts and returns only domain models. It hides details of SQL queries, a schema of the libraries which are used. And then before returning and when accepting, so before returning, it do the mapping between database records. In our case, it's SQL generated structs and domain models. It can also orchestrate multiple transactions, multiple operations into one transaction within the same repository method. So let's think our domain card. Domain model can be represented this way. So, and this is pure Go structs and some dependency libraries, but it has no dependency on SQL generated code. So it's completely isolated from sqlc. And then if we think about repository, then we can express our repository interface this way. It has multiple operations to get the card, add item, and delete the item. But they only accept and depend on the main card, not on the generated. So the idea that we would implement repository and we would delegate to the generated queries generated by the sqlc, and then do the mapping then necessary. So this way we can isolate sqlc and we can avoid them to be leaked into the business logic which uses repository. And one idea here is to create coding agent skills, which will do the delegation and mapping, which will know what are our best patterns and practices to do that mapping and delegation. So that's one of my project on the GitHub. It's called sqlc++. It's a playful name. So what it does, it takes like the output of sqlc. It uses repository interface. It uses domain models and then some reference implementation, or it can be replaced with skills. And then it tries to generate the repository implementation, which delegates to sqlc. Like shown here, and also generate integration tests. All right, so that was challenge 3. Challenge 4 is about batch operations, and batch operations are supported by sqlc. There are special query annotations for that, and it generates the code it uses pgx batch from the driver. So this is how it can look like. Yes, I think I need to speed up a bit. And yeah, so it will use pgx. So in this way, it uses the Postgres pipeline mode, and it's efficient because it sends multiple in a pipeline without waiting for the output of each statement of the query to be executed. So this is an efficient way to like inject a lot of data, insert a lot of data, or update a lot of data. All right, transaction support. So yeah, sqlc is quite friendly to add transaction support. It creates a dbt interface, which is common interface between pgx pool and pgx transaction. And using that one can build a helper method in the repository layer to be able to execute multiple sqlc queries in the transaction. Like in here, we can add and delete item in the same transaction, and effectively nothing would happen. Yeah, I think I skipped this one. For testing repository, even though sqlc is super safe and compile time safe, still like we need some integration testing for Postgres. So I do that with test containers library and Postgres model for that. And here are a couple of Go libraries which can be very helpful to use in the integration test and in test in general. And the takeaways is that adopt sqlc, prefer database mode because it's a bit more. It takes a bit more time to configure, but it's more reliable and more safe. Avoid sqlc generated structs in the business logic. Don't ignore transactions, and think that repository boilerplate code, which delegates to the sqlc queries, can be automated using coding agent and skills. And that's it. Thank you very much for attention.